Okay, hello everybody. I want to show you how to work some of these problems in the math primer in case they're giving you some trouble. And I want to do it in a way that we expect you to work problems in physics this year. First of all, big and small numbers. Now, if you've got a TI-84 or something like that, I've tried to put here on the screen, and all you see are big numbers like that without any scientific notation, you can just enter them. So 549, click up here, 549. 38928 times 62209, and I think if you count you'll see there's 7 zeros, 1, 2, 3, 4, 5, 6, 7. Enter, and you get 3.41 e to the 19th. So 3.42 if we round it, e to the 19th. And it's nice, unless we tell you otherwise, you can usually leave answers this way with 3 significant figures, because we know e to the 19th means that's 19 decimal places. So that's actually quite a large number. Now, we also would like you to know how to enter numbers that have negative exponents. So if you have something like 5.66 e to the negative 13, that actually means 5.66 times 10 to the negative 13, which we type in this way, 5.66. And then the e is under the second comma. And if you're just typing in the negative 13, just do the negative, the sign, not the operation of subtraction, so the one on the bottom, and then divided by 7.88 e to the negative 16. Now, to keep this straight, you do need to open parentheses. So it's open parentheses, 7.88, and then e to the negative 16, that negative 16, close parentheses. And you get a number that's equal to 718, which is the same thing as the 3 significant figures, 7.18 e to the 2. Okay, so next we have unit conversions. One thing we'd like you to get used to is unit conversions when you're dealing with the metric system. So there's some units that you use all the time this year. Centimeters, millimeters, kilometers, those are pretty easy. But also nanometers and micrometers is another one. So you need to learn the conversion factors, and you can get them in your textbook. I think it's section 1.5 or 1.6. 550 nanometers is 550 times 10 to the negative 9. So 550 e negative 9. You can shift the decimal places over and you get 5.50 e negative 7 if you prefer. So for ones like that, and that's now in meters. So when you have something in meters, you have to record the units in your answer. When you have something that's just in the metric system, you just multiply or divide by the conversions. And we're not out to trick you, so there's not very many times where you're going to go from something like nanometers to kilometers. Usually you're going from something else to meters. And the second one, this is a derived unit. So this is one where you're going from 45 inches an hour to meters per second. Now for this, I want you to use the factor label method, or at any rate, one way of doing it is to use the factor label method. And we can insert an equation to show you how that's done. And some of you might remember, but in case you don't, I'll show you right now. Right now. Okay, so you've got 45 inches per hour, and you want to turn that into meters per second. So the first thing we're going to do is we're going to convert, well, there's different orders that you can use, but I think the easiest thing to see is maybe going from hours to seconds. So you get rid of the unit you want to get rid of, which in this case is 1 hour, and you move into the unit that you want to move into, which in this case is second, 3600 seconds. And then I've given you a conversion of inches to centimeters, so we can do that next. So we're going to multiply by 1 inch is 2.54 centimeters, and then the conversion from centimeters into meters is, remember there's a lot of centimeters in the meter, so it's and we want to get rid of the centimeters unit, so we put 100 centimeters in the bottom and we put 1 meter on top. So then there we have it. It's going to be 45 times 2.54, that's everything in the top, divided by 3600 and 100, and that's everything in the bottom. And I'll do this for you on the TI-84 so you see how it's done. So it's going to be 45 times 2.54, so everything in the top, and divided by everything in the bottom, but you just need to put everything in the bottom in parentheses. So 3600 times 100, and close parentheses, and that's it, 3.175 e negative 4. So there's our answer, equals 3.175 e negative 4, and should be there now. And that's meters per second. And then we have literal equations. So this we actually have all the time in physics, where there's equations that you need to find which value goes in which place, and you keep the units in the right position as well. And it's a lot easier if you make what you're trying to find the subject of the equation, and then you just put everything in your calculator at the end. So here I've asked you to find d, little d, when I've given you a big F, a big G, big M, and little m, and you don't need to worry about what any of those things are right now. But let's just start to work with the equation. So remember, the first thing I want you to do, remember the first thing I want you to do is to make what you're trying to find the subject of the equation. So you want to make d the subject of the equation. So if we first of all multiply both sides by d squared, we get fd squared equals gm m. Then we divide both sides by f, and so we get d squared equals gm m over f, and we take the square root of both sides, and so d is going to be equal to the square root now of gmm over f. Next, you put in the numbers that you were given in the problem. So that's going to be equal to, I guess I'll do it up here so you can follow it better. So it's going to be equal to the square root of, the big G is 6.67 e negative 12, and that's times m, which is 220, big M, and little m, which is 42. And all of that is divided by 2.2. So then we can bring our calculator back up and just insert the numbers in the calculator. So that's going to be, if it's a square root, we get that's this second symbol here, so it's the square root of, and then we have some parentheses inside, 6.67, and then e to the negative 12, and then times 220 times 42, and then divided by 2.2. But now you're going to need extra parentheses, because otherwise it's only going to take the square root of the very first thing. So you're going to need to group this. So there's the one extra closed parentheses, and then one extra open parentheses back at the beginning, which I can't quite do. So I'll start all over. So it's going to be the square root, and I did that on purpose, so you would see that sometimes people make mistakes and then they don't get frustrated. So you open parentheses, and then you need another set of parentheses again for the particular number, 6.67 e to the negative 12. So negative 12. Close that parentheses, and then times 220 times 42 divided by 2.2. Close parentheses. So now we're taking the square root of everything inside the parentheses, and that's 1.67 times 10 to the negative 4. So our distance is 1.67 e negative 4. I think we can close this. And yeah, there's our answer. 1.67 e negative 4. So I wanted to do one more, and this is the applied unit conversions. And these are a little bit tricky. I just wanted to challenge you guys a little bit. So the first one asks which takes less time, a banana slug crawling at 3 meters per second, 3 meters at 1 inch every 3 seconds, or a cheetah traveling at 55 miles an hour for 100 meters. Now, for this one, what we're doing is we are effectively solving an equation, but then converting units before we put things in the equation. So this velocity is equal to distance divided by time, and I'm asking which takes less time. So what we're trying to solve for is time. So if we make time the subject of the equation, time is therefore equal to distance divided by velocity. And I'll make it a lowercase time. So we're going to end up with seconds for each of them, or we want to end up with seconds. So what we need to do is just make these conversions into seconds. Looks like the easiest thing to do is going to turn that 1 inch in the first one into meters, then we'll get meters per second. So we're talking about a banana slug, and if you've ever seen banana slugs, you know this is about how fast that they crawl. So 1 inch is equal to 2.54 meters, which is equal to 0.0254 centimeters. And so when we want to find the time, time is distance divided by velocity. That's going to be equal to a distance that's 3 meters. I got that mixed up. 1 inch is 2.54 centimeters, which is 0.0254 meters. So distance divided by velocity is 3 meters, divided by velocity, which is, and the velocity is 0.0254 meters per 3 seconds, like that. We can call up our calculator, and we have 3 divided by, open parentheses, 0.0254 over 3, close parentheses, enter, and that gives us 354 seconds. The moral of the story is if you see a banana slug crawling at you, you don't really need to get out of the way too fast. I guess it would be good if you are able to look at the problem and imagine that a banana slug crawling at 3 meters is going to take a lot longer than a cheetah traveling 100 meters, because cheetahs are pretty fast. But in case you need to work out the math, we're going to start with our 55 miles an hour, and we're going to convert that into meters per second. So there, I gave the conversion factors above. There's 1609.344 meters in a mile. So, and hours and seconds we know already. So it's going to be times, the easy one is 1 hour in 3,600 seconds. And then the somewhat more difficult one, but still not too difficult, is 1609.344 meters in a mile. So 1 mile is 1609.344. If we then get our calculator, we have 55 times 1609.344 divided by 3,600. And that gives us 24.6 meters per second. So if we want to find the time, time is distance over velocity, which is 100 divided by 24.5872. We can go to the calculator. We can say 100 divided by 24.5872, and it's about 4 seconds. So as expected, the cheetah is an awful lot faster than the banana slug, but they don't compete very much in nature. Okay, I hope you enjoy these problems, and come by if you have any other questions.